So this is going to be a general overview of how to do the electronics for the Gato 9300. And we're going to start from the front, work our way to the back. But what I wanted to show you first was where all the electronics are stored. And this looks like a mess. And for most people, this is considered a mess. For me, this is okay because I'm not finished. I'm working on creating a battery tray and some other brackets and whatnot to hold all the electronics. But I'm going to explain this whole mess in a much simpler way. And then once you put it together, you'll see what I'm talking about. So let's move over to the table. And the table is going to explain everything from the machine so that you know what to do. Now, the video that shows how to assemble the machine is all about the parts, screws, and attaching. There are other parts of the video that show how to install the motors. And part of the video is focused on the hydraulics. Now, the hydraulics and the electronics, the positioning is pretty much the same. The routing of all the pipes and everything like that, the hoses and wiring is the same, but in general, the hydraulics is much more complex of a solution. So I tried to do a video of putting that together, but I didn't do one for the electronics because I figured this would be a lot easier and simpler to understand. So what do we have? We have 4 motors, so 2 in each axle. We have another motor in the middle here for the articulation. We have 3 linear servos. Okay, that's these guys, and they go in and out, and they're for the boom and the bucket. And I'm going to show you how to connect all this because some of them come with wiring and how they function. This is for the novices out there who don't know how this all works but still want to build it. We'll walk you through this. Next, everything has to go through an ESC, which is right here. I use these little tiny ESCs. They work really well for what I'm trying to do. But for these motors, I used a much bigger ESC. Notice there's a difference. This little ESC is good for the linear servos, and that ESC is much better suited for these motors. So when we go and install everything, you're going to install the hardware first, and then you're going to run all the wiring to the back. Now, what's the difference here? This linear servo comes with a wire that is just long enough to get you to the back here. But these motors, as you can see, have nothing. So you're going to have to get your own wiring. Now, what wiring works best? I used something around the 22 to 24 gauge wire. So you just buy a bunch of wire on a spool. Black is preferable. And then you're going to run that to the wires. And in the video, I show you how to wire up these motors. This motor here, the center motor, is the same, but it goes by itself to the ESC. So what do we do? Well, let me explain. To get this to work, the linear servos, let's start with that. You're going to need to run power to this. There's a red and a black wire. And at the end of it, you have this connector. It's up to you if you want to use this connector or you want to chop it off and wire it directly to the ESC. What type of ESC is important as well, because you don't really want to get a ESC that's too big, that's providing way too much power for this tiny little thing. So you don't need anything that big. This is called a tiny ESC, and it's from FingerTech Robotics. It's here in North America. You can buy it. They're about $30 Canadian. I know you're probably like, ooh, that's expensive. I've never had one of these things go bad on me. Actually, I lie. I had one that went bad, but they'll replace it for you. If you're in Europe, Magom has something real similar. I think they're called a BC5 or B something 5. Check out their site, Magom HRC, and they'll have tiny ESCs like this. They'll be able to handle the power. And look at the size. It's very, very small. So this will fit in really tight places. So how does this all connect? Well, the ESC has 4 wires on one end and a servo lead on the other. What we want to do is we want to take 2 of those leads And it usually will define on the ESC which one goes to the motor and which one goes to a battery source. Every ESC needs a battery source, and every ESC is going to need to go connect to the motor. So in this case, this linear motor needs to connect to this ESC. Now, does it matter which wire goes where? No, not particularly. And what I mean by that is if we go purple to black and blue to red, and it doesn't go the direction we want when we pull the stick, that's fine. You can just reverse it on the controller, right? The receiver, or sorry, the transmitter. So in the transmitter, you can adjust forward or backwards. So not critical. What is critical is the power. So you need to make sure the red goes to red and the black goes to black for the battery power. Another thing you can take in consideration is because we have one linear servo for the bucket, there's two for the lift, the boom. Now, that's interesting because we have to make sure that these two wires are being connected the same here. So the black from this linear servo and the black from the one beside it need to go to one of these. And the red from each cylinder will go to the opposite one. So we want to make sure both linear servos go up and down together. So you'll need to create like a Y harness or just somehow solder these two together or wrap them around and solder them here or make a connection. That's up to you how you want to do that, but essentially that's what the plan is here. Now, another important thing to keep in mind, connecting the servo end to your receiver, right? This needs to be connected on whatever channel you plan on using. Some receivers have 6 channels, some have 10, some have 12. That's up to you on what type of controller you have, transmitter, and you're going to plug it in. Now you notice every servo wire has 3 wires. One's a ground, one's a power, and one's a signal. For the purpose of this build, I would tend to say that the ESC that drives the steering or these motors should have all 3 wires connected. And then that will connect to your receiver. Everything else, the linear servos or the center, the pivot, these all have to take the red wire out. Now, we do that because we don't need to drive power for every single part here on the receiver. Only one ESC will deliver the red to the receiver for power. The others will be disconnected. It creates issues when you have multiple reds in there, and you'll find that either one motor won't work or the other one won't work or this one works and that one doesn't. Just follow this path. One ESC has all 3. The rest take the red wire out and then make the connection. So we have this laid out. The motors are going to connect here. Okay, so this connects direct, and you can also connect that way. And you'll do that for all your motors. Now, the important part here is once we're done powering all this, the ESCs need to get power. So the ESC will need to go to the battery. Well, to go to the battery, we need to have some sort of main connection. You can do it in either soldering everything together into one big ball, or get yourself a little board that has multiple, this has hot glue on it just to cover the ports, but I just got a drone power distribution board, and I just connected all the blacks to one point and then all the reds to another. So find yourself a power distribution board. It's easy to connect all your ESCs. Now in this situation here, I have everything connected to the receiver. All the servo leads go to the channels that I want them to be on. And then everything goes to the ESCs. There's a bunch here. And then all these ESCs go to the separate motors, right? They're all cut off right now because I'm building something else. All the power from every ESC goes directly to this distribution port, which then goes to the wires that hit the battery. Now, what type of connector should you use? There's the Deans like this. It's all right. Or you can go get these. And these are XT60s. They're a little bit bigger. You solder on your wires. And in this case here, I like using an 18 gauge wire, and you solder it on here. And if you really want to make things special, you can get a switch. And put the switch between the power and the lead here so that you can turn it on and off with the battery still connected. So that all goes this way, connected there. And then the switch goes before it, which then leads to this. And this is just a quick, easy setup. How to connect everything up. If you have any questions, want to learn more or understand how to better do it, please leave a comment in the description or the comment section, and we'll get back to you and show you how to do it properly. But essentially, this is the basics on how to wire it up. How you run the wires through here, you're going to run them through the spots that I mentioned in the build video. How to wire up these motors is in the build video. But everything else here, this is kind of make your own salad. And that's it for the wiring. Enjoy the build.